is Aries, and the subject of this talk are neural networks in finance. So, I'm sorry. Okay, so ASI, as a consultancy, have a lot of clients from the financial industry. And so, okay. Sorry. Yeah. And so they were very interested in knowing whether you could use artificial intelligence to predict the markets. In particular, they wanted to know whether you could use a neural network to do that. Now, this is a very simplified view of how trading works. You have a quant researcher who looks very hard at financial time series and tries to find a signal. And when he has found a signal, the trader can use that to place orders on the stock exchange, and hopefully at the end of the day, you make a bit of money like that. Now, increasingly, in recent years, the execution is done by computers, partly because you can trade a lot more, and also because they're more reliable. And in the future, it could even be the case that you can replace the researcher with a machine as well. Now, during my project, I worked on two different kinds of strategies. I started with high-frequency ones, and although you can get some results for these, I decided to focus on the lower-frequency ones because they're more useful to your average trader. So the data that I use is public data, widely available. I took 1,500 stocks that were traded continuously on the NASDAQ stock exchange in NYSE between 1995 and 2017. The goal of the strategy is to know whether given stocks' return are going to outperform the median return in 10 days in the future. And this is based on a paper by Takeuchi and Lee. So what is a neural network? A neural network is made of neurons. And a neuron is a very simple mathematical device which takes a weighted sum of its inputs, and if this is above a certain threshold, it'll fire, and otherwise it won't. So a neuron on its own is not very useful because it's very simple, but when you combine them together in a network, you can build arbitrarily complex classifiers, and provided you have enough data for them, you can detect very complex patterns. So what inputs are we going to feed our network? Actually, some very simple inputs. All we're going to give the network are the normalized cumulative log returns over the last 10 days. And this is an example of a stock which did pretty well because it ended up one standard deviation above the mean return after 10 days. And to give a longer term information to the network, we're also going to give the cumulative log returns of over the past 10 groups of 10 days so that the network can choose which time scale is relevant for the problem. Now, financial time series are very noisy, and so to reduce the noise, we can use what's called an autoencoder. So an autoencoder is a very simple network which maps its inputs to a small set of nodes and then attempts to reconstruct the inputs from this small set of nodes. And because there's a small set of nodes, you're forcing the network to learn a low-dimensional representation of the data. For a time series, that means that after going through the autoencoder, what the network sees is actually the orange curve here as opposed to the noisier blue curve. So this is what the full network's architecture looks like. You feed the inputs, they go through a denoising part, then through a classifier, and at the end of the day, you get the probability predicted by the network of the stock doing better than the median in 10 days. So this is an example, a typical example of the outputs of the network. So it gives you a probability for every stock. And that means you can rank the stocks from top predicted performer to worst predicted underperformer. Now, how do we use this to make money? You could use the signal in any number of ways. But a very, very simple strategy that you could use would be to buy the top 10 performers every day and sell the top 10 predicted underperformers every day. And that way, you do not have to invest any capital because you buy for as much as you sell every day. And in 10 days, you'll just close your position. So does it make money? Well, yes. So for example, if you were to do this for 10 years, buying and selling 10 stocks, you would end up after 5 years, ending up with 20 times your daily position. So that means if you were buying for 1 million worth of share every day and selling 1 million pounds worth of share every day, you would end up with 20 million pounds worth of share, having invested no capital. Now you can see also that as you buy and sell more stocks, the performance decreases. And this is because the signal for these stocks that you're adding is actually weaker. Now, you might also be worried about whether transaction costs are a problem, but after assuming, say, 0.1% transaction cost, you're still making quite a bit of money. So these results are promising, and it looks like artificial intelligence has a future in finance. Thank you.